Good afternoon to everyone out there. I'm Tony Bergantino, Director of the Wyoming State Climate Office and the Water Resources Data System. We're in the Department of Atmospheric Science down here in Laramie. And thanks everyone for joining us on this June conditions briefing, which is put on by my office and the University of Wyoming Extension, U.S. Geological Survey. We've got the U.S. Bureau of Reclamation and the National Weather Service up in Riverton. State Engineer's Office is on with us. We've got the Missouri River Basin Forecast Center, and then we have also a special guest with the Western Water Assessment. And today we'll look at current drought status and conditions, reservoir conditions, stream flow, the Water Rights Administration. We'll get into some weather forecasts, outlooks, water supply, and then for the highlight of the month, we'll have the Western Water Assessment give us an overview of their dashboard of conditions. So jumping into current conditions, we'll start out here with the latest U.S. drought monitor. This goes through Tuesday, which was the 24th, and was just released this morning. Much of the north is now completely drought-free. That gray area up there with no D category at all. We've had improvements there, and in the east, thanks to some good bouts of precipitation here over the last few weeks. But unfortunately, that precipitation gave the west and southwest a bit of a miss, and we're seeing some degradation start to kick in there. And the whole western area here has been quickly drying and experiencing a quicker onset of drought conditions. Over here on the left, we've got the drought map from exactly a year ago, while the one released today is sitting over here on the right. And comparing the two, we can see that much of the north is better off now than it was a year ago, mostly being changes from D0, or that abnormally dry, not actually drought, to no drought condition at all. On the south and west, though, conditions are worse, having gone from no drought or abnormally dry conditions to D1 or D2, and that's moderate or severe drought. I guess one consolation in the east here is that although conditions are worse than they were a year ago, they're at least better than they have been in previous weeks. So there's always that little silver lining. So looking back here, look at the last 25 years or so of the ebb and flow of drought conditions in the state. We see at present that the current cycle, one that started in late 2023, has been dropping off, although the level of D1 or moderate drought has actually started increasing here again in the last few weeks, even as the severe and the extreme drought, the D2 and D3, has decreased. While the amount of the state that is in no D category has gone from just over 77% that we had during the last webinar to sitting at 64.9% now, the level of actual drought, those D1 through D4 categories, has gone up from 38.6 to 44.33%. And those changes can be seen a lot easier when looking at just the last almost 5.5 years now. The amount of state in no D category at all has increased to 35.1%, while the D3 or extreme drought coverage that was present during the last webinar has disappeared, and the amount of D2 or severe drought has gone from 17.64% down to just under 5.5%. Even though we did have the D1 go up. And a lot of that is because, you have, when you go down from those higher conditions, D3, D2, and then you go into a D1 condition, so there's going to be more of it there. But we've also had an increase in the D1 down in the southwest part of the state, so that's contributing also to the increase in the area that we're seeing. All right, show precipitation over the last 2 weeks in terms of percentiles. Lack of precipitation in the southwestern quarter of the state can easily be seen here, especially that large area of dark red, which represents areas receiving the lowest levels of rain, the 2 percentile and below. The area extends northwest, at least at lesser levels, into the Winds and Bighorns. All's not gloomy though. Areas like Park County and much of the Northeast and east central Wyoming, though, have been above median. If we jump back and look at the last 3 months, you can see somewhat of a northwest to southeast kind of dividing line with the west and south, even extending over into the far southeast at lesser levels, but that whole area being below median. And then to the northeast of that line, northeastern, what, 2/3 or so of the state has been at median. That's those areas in gray to above median, and that's represented by the greens and even small blue and purple areas on the map. All right, over here on the left, we have the water year representation. That's precipitation as a percent of normal for the water year. And then over here on the right, we have the calendar year, and they're starting to look even closer to each other now, as we get further into the year. Where there are differences, the calendar year over here does show it to be a little bit wetter, pretty much in all cases, except down here in the far southwest, where the water year does appear to be a little bit wetter than the calendar year. And that's unfortunate, because that means that area is, and it's a sort of a proof that the area is kind of deteriorating, receiving less precipitation here in the present compared to the longer term average. Okay, here we have the standard precipitation index, or SPI map, since it's a little easier to say, for the last 30 and 60 days, as well as 1 year. And since it's been a little while since the SPI has really been described during the webinar, I'll just take a minute to explain them. The SPI takes raw precipitation totals over different time periods, month, 2 months, 3 months, 6 months going back. And then it fits those totals into a statistical distribution. And from that, you can calculate the probability of a particular amount of precipitation happening for one of those given time scales. And that probability allows us to compare precipitation better across regions that have different climates. And because the drought monitor is based upon the probability of various conditions occurring, the SPI and its variants, the SPEI, which includes evapotranspiration, those are very useful for classifying the drought levels. And so we look at those fairly heavily, sometimes even more than just looking at what the precip percentiles or percentages have been. But at 30 days up here on the upper left, we see strong dry signal in the west and southwest, which is where we see most of that degradation in the drought monitor. 60 days here on the upper right, we see much of the same pattern, but a little bit lesser magnitude. The dryness scale is backed up a step or two, and that indicates that the decline has increased more in the last 1 to 2 months, comparing the two. East is still showing some wetter conditions, although the extent has decreased when looking at the 30-day versus the 60. And then looking at what the last year here down on the lower right has been, although the intensity in area has decreased since the last webinar, especially here in the east, the rest of the state is either at normal conditions or below normal. Not very much of that blue or wetter conditions showing up here when you look back 1 year. All right, we'll jump over here to temperature now. Seeing some minimum temperature averages over the last 2 weeks. We're finally above freezing statewide. We'll have that couple week period where we can actually say that. Other than the bighorns and medicine bows, the lower temperatures would be found in the west and the Green River Basin. The warmest was the lower elevations of central Wyoming, Bighorn Basin, and then of course the eastern plains, northeastern areas, where lows only down into the 50s, mid-50s thereabouts. So looking at those minimum temperatures in terms of a departure from normal down here on the lower left, by and large above normal across much of the state, with a few areas in gray, which is about normal, or even some green spots in the southwest, which were just below normal, with a sort of a negative departure from normal. The greatest positive or above normal departures were north of the Medicine Bows, Laramie Range area, then along with some of the mountainous west and south of the Wind River range down in here. Daytime highs over the last 2 weeks, upper 50s on up into the high 80s. Central Goshen County saw the highest highest temperatures, followed by Central Platte, lower elevations of Fremont County, and some various other areas in the sort of the central third of Wyoming, going from like the Bighorn Basin south, that central third as you go east to west. Those saw highs in the mid to upper 80s as well. If you look down here on the lower left, while average maximum temperatures along the Montana border were near normal over the last 14 days, 2 weeks, south of that was above to well above normal. The southern Bighorns and the west and southwest saw temperature departures that were more than 4 degrees. But for the most part, the greatest temperature departures were seen in central and south central Wyoming, where the 2-week average high temperatures were in excess of 10 degrees above normal. Jumping underground to the soil moisture, it's continued to get worse. The west continues to intensify, and it's been spreading across the southern part of the state, while the north has gone from, it's gotten drier. Areas that were on the wet side and or neutral are, well, the wet side is now neutral, and the neutral areas are moving into that 30th and 40th percentile. So we're seeing soil moisture conditions get worse pretty much statewide. The only area of improvement was a little area up here in the northwest that went from that 0 to 2 percentile up all the way up to the 2 to 5th or so. All right, I'm just putting this one up here so we can get some closure on the snow season. All the basins are either melted out or their snowpack levels are at the point where the percentages are not really worth mentioning. They're not valid for the area. Being at 500% of normal here in the upper North Platte doesn't mean much when the current snow water equivalent is under 1/10 of an inch. This is just here, like I say, for completeness. And you can see same sort of situation here last year. Couple extra basins have something here measurable, but by and large about the same across here, and not really not worth getting into the numbers. All right, we've gone over this table quite a bit here, as the snow season progressed and we worked towards the peak and past it. And the peak information on this hasn't changed since the last webinar, so we'll concentrate this time on these last 2 columns, which are it's the current snow water equivalent, and then the very last one here is the melt out date. At this stage, we can ignore the snow water equivalent as well, except for the fact that most of them are 0 or up to maybe 1/10 of an inch. The last column is the median date of melt out, and if you click that IMG link there next to the date, you can retrieve a graph of melt out dates for about depending on the state or the basin, about the last 40 or so years. I won't go into all of them, but let's take a look in summary at what happened around the state for this season. So this is an example chart you'd get when you clicked on that melt out link on that last slide. This graph is of the Laramie Basin, with the dots representing the melt out date for each year going back to about 81 to about 1983. And the green line is the median, and the orangish line is a centered 10-year running average that's put over it. And you can see a little bit of a downward trend in the running average, meaning that the melt out has been occurring on a whole a little earlier over time. If you look at other basins, there's either no discernible trend in the orange line, and some of them have an upward trend. So it's a mixed bag of what you can get as far as putting that trend line on there and looking at the melt out dates. And like I said, I won't bring up the graphs of each basin, but there's a summary here on the left showing first the basins that melted out early, and well, most of them are falling into that category, 12 of the 19, in fact. Below that are the 4 basins that melted out later than the median date. Then in the second column up here, we have the only basin that melted out right on the median date, and that was the Laramie Basin. And only the upper North Platte technically is still not melted out. I mean, it's under a tenth of an inch, so we're within days of it officially being melted out. And then we're done. But the number in parenthesis next to each basin is the number of days early or late that it melted out. So the ones that were late, only the Little Snake was more than a day later than the median melt out. But when you look at the ones that were early, they range anywhere from 3 days back to 17 days early on the melt out there. And that melt out from those basins is what contributes to our stream flow. So let's go over to Aaron Fiaschetti, who's with the USGS, and he'll talk about the surface water situation. Go ahead, Aaron.
Hi, I appreciate that, Tony. So here we are looking at current conditions for the state, and I'll just kind of run through the colors on the map here. So what the USGS considers a normal stream flow is a 25th to 75th percentile. So the 25th being a lower flow when it's ranked in a percentile, and the median or the normal would be the 50th. So the green could say it's anywhere from a lower stream flow to a higher stream flow, but it's normal for this time of year. We don't really have to go much into the above normals because that's not where we're at right now. But looking at the lower flows below the 25th to the 10th is the oranges below normal. And then the reds, which we have quite a bit of, are much below normal, below the 10th percentile, or the bright reds are an all-time low for this day. So there's a few of those through the state. And this is real-time stream flow from the National Water Information Dashboard. So we'll just bounce around and talk a little bit more about where we're at right now. So right now this is a hydrograph from WaterWatch that the colors match the percentiles that I talked about before, but this is a accumulation of stream flows throughout the state. And on the vertical axis, it's a 7-day average in millimeters. So it's a runoff per square area. It's a little bit black boxy, but it's given us an idea of kind of where stream flow should be at. And we're somewhere around the peak, a little bit past the peak of snow melt, and on that falling limb of the recession of that peak flow. I wanted to talk a little bit about the significance of runoff. That's when water's abundant, when the water's coming out of the mountains. And in that kind of 4-month period that the NRCS forecasts from April 1 to July 31st, that's the majority of the water supply. If your water's coming from the mountains and it's coming from snowmelt, that's when most of the water kind of comes through the basin for the given year. So if you kind of look at this bar graph over in the lower right-hand corner, just showing a few basins in the area where you're showing that of the annual stream flow that in this period of runoff in the North Fork Shoshone, Middle Fork of Powder, you're getting nearly 80% of that water volume is coming through at that time of year, and in pretty similar conditions for the North Platte, and then and a little bit lesser in the Snake. But the majority, the story's all the same, is that this is when your water comes through, and if you fall short on your runoff, it's going to be pretty hard to make up to have an average water year, and having an average, kind of having an average volume over the year is not the only metric to kind of justify a good water year, but it's a pretty close one. So we're right at that point where we're in the runoff. We're kind of coming away from it. If your stream is connected to the mountains, if it's a little bit more in the prairies and foothills, then your kind of runoff is kind of past and you're into a different kind of lower flow period. So moving on. So this is just kind of looking at where we're at to date and just kind of giving an up down arrow of what kind of water year we've had so far. And I know Tony mentioned that we've had some earlier melt off, so that can kind of skew this a little bit. But I think looking at a cumulative flow from April 1 to June 22nd gives a pretty good idea of where you're going to kind of shake out with your runoff. So, in the North Fork, the Shoshone and the Belle Fourche are above the median, as well as the Snake River above the Palisades. And then kind of as we go a little bit farther south, the green at Warren Bridge, the Wind River above Boyson, and the Middle Fork of the Powder are below the median. One note on the Wind River there, if you looked at the hydrograph for the Wind River near Du Bois, flows are quite a bit lower there, but when you're a little bit farther downstream above Boyson Reservoir, things are a little bit better. And then looking at the North Platte above Seminole, that cumulative flow is below the median, or below the 25th percentile. So there's still some time to accumulate flow volumes through July 31st. But if the snow melt's gone, that's kind of your dependable water supply, and then you're kind of relying on some major widespread precipitation to really boost those numbers up, especially if you're below the 25th percentile or even below the median. It might take a fair amount of precip to kind of get you to the median conditions there. So we'll kind of bounce around to a couple hydrographs around the state. So looking at the North Fork of the Shoshone, we're going to kind of focus on that black line, and you kind of see right into in May and June, you kind of see some peaks that look like they're a little bit ahead of schedule with runoff coming off, putting those flows up into the 75th percentile or above. And then since kind of June 1st, that appears to be the peak for the year. Right around then, flows have been decreasing quite a bit, and we're kind of approaching that 25th percentile flows, so that things coming off a little bit earlier and maybe not enough precipitation to kind of support those flows as they decline into the falling limb. But we're at a point where there's pretty good water supply around in the North Fork of the Shoshone still, even with lower flow conditions. Moving over to the Middle Fork of the Powder, looked like, the runoff and the peak around in May, the middle of May, had a bit of a bump there, but things look pretty reasonable, pretty normal around the median, kind of around the bell of the curve there. And then as we've kind of coming into the falling limb, things are kind of coming pretty close to the 25th percentile. And sometimes you'll see that, and we can talk about that more next time, is when you're have some prolonged dry conditions on seeing effects on base flows later in the season. But for now, it seems like things are pretty close to the 25th percentile, and it's going to take some precipitation to bump that up now that the snow melt's mostly gone. Moving down to the Little Medicine Bow River near Medicine Bow. There wasn't really much of a runoff there. Things kind of came up in early March and just held steady through June. Not much for snow melt in that location, and that's one of the near some of the drier areas in the state in regards to drought there. So since that period, things have hung really close to the 25th percentile and a little bit below on that black line. And then bumping over to the Snake River above Palisades Reservoir is pretty pronounced here, seeing that early runoff there and a bump in May and a bump in June, pretty similar to what we saw on the Shoshone River. And then very similar, seeing flows kind of dive off into the pretty close to the 10th percentile there right now. Is snow melt has kind of moved through the system. So just moving on here to just looking at drought and stream flow, and this is a screen grab from the National Water Information Dashboard, and just kind of showing how all our gauges kind of showing their kind of normal conditions, below normal, much below normal, and how that kind of aligns with the drought degradations. And they don't always, they jive well in some places and they don't always jive well in others. And we'll talk about that more in the future, where we've kind of identified some gauges in Wyoming that we think are pretty good representative gauges of looking at how the drought on the landscape affects stream flow. But in general here, it seems like things align pretty well. And then there's some gauges that are probably showing that they're normal conditions, but they're generally probably below the median. Most green ones are on the map. So they're still in pretty dry conditions here. And then let's see, where are we moving to now? Oh, reservoirs. So, this is a time of some generally abundant stream flow. So it's a time where reservoir storages should be kind of increasing or kind of topping off reservoirs. And if you look to the screen capture from the climate office here, that most reservoirs, the boxes are mostly blue and there's not a lot of white in general throughout the state, but you can see some like Pathfinder and Seminole on the North Platte are not, there's quite a bit of white. They're not full yet. I'm not sure if they'll get there, but it's been kind of a mixed bag since we last talked to you. There's been some pretty large increases in the Wind River reservoirs, Fontenelle and the Snake, and then some pretty minor changes in Keyhole, Seminole, Pathfinder, and Flaming Gorge. So there different amounts of water have been stored depending on conditions, but there's going to be folks to talk about that more in depth next. So thank you.
All right, thanks, Aaron. So for more on those reservoir and water operations around Wyoming, we have George Finnegan and Crystal Lesmeister with the Bureau of Reclamation. We'll start out with George. So go ahead.
Yeah. So as Tony and Aaron just covered, we've had kind of a poor year for inflows, particularly for the North Platte being below the 25th percentile. Here we've got the Bighorn Wind River system, and Bull Lake is 70% full. That's quite a bit better than we were last month, but we're not expecting to fill this year. Due to poor inflows, reservoir releases are being made primarily to meet irrigation demand. Yeah, Boysen's 84% full and Buffalo Bill is 91% full. Releases currently are 392 CFS for Bull Lake, 1150 for Boysen, and 1350 CFS for Buffalo Bill. And here's the North Platte system. You can see we're doing quite a bit worse. We do have a large storage capacity for the North Platte, and we're mostly relying on that this year. We do have inflows, but they're quite a bit below average, even quite a bit below what we received last year. Seminole's 48% full, Pathfinder's 51% full, and we do have Glendo filled for the summer irrigation season, and this is the peak right now. It's going to be coming back down as we meet that irrigation demand. Other comments for this slide? Yeah, Upper North Platte Sinclair inflow peaked June 2nd and 3rd with approximately 3,100 CFS inflow. It was nice to see that, but like we discussed, our inflows are well below average. Next slide. And finally, we have 1,500 CFS in the Miracle Mile below Seminole and Cordis, 2,300 CFS below Gray Reef, below Pathfinder and Alcova, and we're releasing about 3,300 CFS out of Guernsey, and we're matching that plus or minus gains out of Glendo. The Wyoming Area Office will be lowering the water level in Guernsey Reservoir in preparation for the annual silt run. Silt run is an operation which provides silt-laden water to Goshen, Gering, Fort Laramie, and Pathfinder irrigation districts under contract with Reclamation. As the silt-laden water gets diverted into an irrigation canal, the water slows down and the silt sinks to the bottom of the canal, reducing seepage and conserving water. Guernsey Silt Run is scheduled from the 11th to the 24th. Glendo release changes will occur from July 6th to July 10th, to empty Guernsey while continually meeting irrigation demand. With Guernsey Reservoir down, the silt gets pulled out of the reservoir and meets the silt run requirements. Glendale will release extra water from July 24th through the 27th to refill Guernsey and end the silt run. That's it for me, Tony.
All right, thanks, George. And we'll go to Crystal for the northeast part of the state.
Hi, I'm Crystal Lesmeister. I am with the Dakotas area office, and I'm located in the Rapid City field office in Rapid City, South Dakota, and our office operates Keyhole Dam. Like you said, Keyhole is kind of up in the northeast corner of the state on the Belle Fourche River, and it's mainly used for irrigation and flood control. We're currently about 60% full, and our current release is 0 CFS. Our releases are just based on irrigation demand, and we'll likely see that irrigation demand increase here in the coming weeks.
All right, thanks, Crystal.
Thank you.
And now, given everything that you've heard, you can possibly imagine that we'll be also hearing from Michelle Hubbard at the State Engineer's Office to update us on any new water rights administration that we might be happening. Michelle?
Hi, Tony. Thanks for the introduction. Again, my name is Michelle Hubbard. I'm with the State Engineer's Office, and this is just a general map of our 4 water divisions. They're each kind of located based on major drainages, and we actually have calls in all of them. So how exciting. So this slide, I've denoted any new calls since our last meeting in bold. And so in Division 1, all of these calls have been in effect since roughly April or May. And it's fairly common if you have no to little precip or runoff in the spring when irrigation demand picks up. These calls will most likely last the rest of the summer. And so if you go to the next slide, there are 2 new calls in Division 1, which is Bates Creek, which is by Casper, and then the Laramie River by Laramie, obviously. And so those are 2 new calls in Division 1. Moving to Division 2, just this week, there was a new call placed on French Creek, and it was regulated back to 1884. And really quick, I guess those dates are just the priority dates of the call and not necessarily what all water rights junior to 1884 are being shut off. That's just the kind of the maximum. And so water regulation is very complicated. And so if anybody has questions, always feel free, shoot me an email or give me a call after this. All right, Division 3, the winds. Oh man, okay. I thought I messed up my slides. Okay, Division 3, again, so all of those non-bolded creeks have been under regulation for at least the past month. And then there's a new call in the North Fork and Owl Creek, and those are regulated back to 1900. And last but not least, Division 4, a lot of these came in at the end of May. And so the Smiths Fork is under regulation for multiple different rights. Burnt Fork is under regulation to 1878. South Piney under regulation to 1886. Henry's Fork is regulated to 1899. And then the Bear River is regulated for compact compliance. And that is all I have.
Well, that's enough. Thanks, Michelle.
Yeah.
All right, jumping forward and looking into the future, we got the outlooks and forecasts from Lance Vandenbogart with the National Weather Service up there in Riverton. Lance?
All right, thanks, Tony. So here's your typical hazard calendar for Wyoming. You can see that we're well into fire weather season now, and river flooding has kind of tapered off as we've been talking for most of this webinar with the flows, snowmelt going down, but we're still solidly in that flash flooding time frame in the summer where we can get those big thunderstorms that cause very localized issues. and well within our severe thunderstorm time of year as well, with mentioning tornado there. There are risks of tornadoes, but really more often it's those gusty winds across Wyoming that cause the most damage. All right, we'll go ahead and look at the next week as far as precipitation goes. You can see a lot of green on this, but those colors of green don't really denote very much precipitation. And also this is an average, and this time of year, a lot of this precipitation ends up being small lines of heavy precipitation where showers and thunderstorms track oftentimes to the northeast or to the east across the state. So, you know, a week from now, the preset map is not going to look like this, but you can get the sense that there's going to be more showers and thunderstorms across the eastern quarter of the state, as we would expect when we get that high plains moisture that kind of butts up against the Bighorn Range and the Laramie Range. We do get more thunderstorms in that area, but there's no big wet system that's going to cause a widespread wetting rain for any part of Wyoming over the next week. If we look a little bit further into the week after next, July 3rd through the 9th, you can see that above average temperatures are favored for especially the Yellowstone northwestern corner of the state, but the whole state is leaning towards above normal temperatures. And then precipitation wise, it does look like we'll have a little bit of a monsoonal push for the week after next, where you know, Arizona there is well above normal, but then a little bit of that moisture comes up and will could affect the southern part of the state. Therefore, we have a solid lean towards above normal precip across the state in this 8 to 14 day window. And then looking a little further, what does the rest of July bring? You can see that overall, we're still expecting temperatures to be above normal statewide. But then, presumably the middle third and last third of the month of July is going to be drier than average. So overall, the month of July looks fairly high confidence for below normal precipitation, especially in the north, which is the areas where that monsoon moisture is least likely to reach. It's really the southwest that oftentimes gets that when it's not a very strong push of moisture. All right, and then looking to the kind of late summer, early autumn outlook here. So this is a 3-month average, still leaning towards above normal temperatures, especially in the west. And then that same signal for precipitation, although a little weaker, is showing a lean towards drier, especially in the northern part of the state there. All right, I think that's all I have for you guys.
All right, thanks, Lance. And now for a quick look at water supply outlooks, we have Alex Carruthers with the Missouri River Basin Forecast Center. Alex?
Thanks, Tony. With the snowmelt season essentially over, the river flooding threat for Wyoming for the remainder of the season is forecasted to be below normal. No surprise based on what we've talked about. But as a reminder, both the NRCS and the National Weather Service produce water supply outlooks, which represent the volume of water expected to pass a given gauging station during the spring and summer months. The dots on the map shown here indicate locations where the water supply outlooks are produced by the National Weather Service. We issue these outlooks once per month near the beginning of the month, January through June. So we are now finished for this season. The map here shows the April through September volumes for the Columbia and Missouri River basins issued by the Columbia and Missouri River Basin Forecast Centers. And then the Colorado River Forecast Center issues theirs April through July. The official forecast was issued at the beginning of June, but what's shown here is a more realistic snapshot showing the conditions as of yesterday. The point of this map is to show that many locations across Wyoming are forecast to only see 50 to 90%, the oranges, yellows, and reds, of the normal volume as compared to the 30-year average. So as previously discussed, the primary concern this year will be the forecasted lower than normal runoff volumes for most locations.
All right, thanks, Alex. And now for our highlight of the month, we have Seth Ahrens with the Western Water Assessment, who's going to go over their dashboard of climate and water conditions. And to facilitate that, I will stop sharing and allow Seth to share.
Oh, I just need to send a request to share. Well, my name is Seth Ahrens. I work as a research scientist for Western Water Assessment. Western Water Assessment is a NOAA funded program. We're based out of the University of Colorado, University of Utah, and University of Wyoming. And I just wanted to give a real brief overview of what my organization is and does before I talk about one of the climate products that we have on our website, the Intermountain West Dashboard. In general, our mission priorities are to conduct innovative research in partnership with decision makers, helping them make best use of science to manage for climate impacts. And this includes working directly with communities and water systems to help build resilience to compound hazards, advancing user-relevant research on climate change, snowpack, wildfire, and water supply, and integrating and prioritizing social science research techniques throughout the work that we do. We're funded through a special NOAA program called the Climate Adaptation Partnership Program. This is a relatively small program within NOAA, only about a $6 million annual program that funds 13 regional programs. This particular program has been around since the late 1990s, and Western Water Assessment was funded first in 1999. As with many things moving forward with federal funding, the future of this program is somewhat uncertain. Overall, the program's goals, general goals, kind of mirror what our organization's goals are, and that's to build relationships that help local decision makers and researchers collaborate on adapting to climate change. The CAP program expands our nation's capacity to adapt and become resilient to extreme weather and weather events and climate change. And two of our large priorities are to help build resilient water systems and communities that are more resilient to changes in climate hazards. And this work can include working on climate-related issues such as water resources, and those specifically, we do have a focus at times on Colorado River Basin water issues, drought, snowpack, wildfire, climate science, climate adaptation, and resilience to compound hazards. What this work actually amounts to, the actual things that we do, this includes original research, but that research is really grounded in real world needs. So by developing relationships with different users of climate information, we better understand what their needs are and can work with them directly to develop new research as needed. And our work really brings together a vast array of expertise in both physical and social sciences. Sometimes this work is not original research, but integrating research. So what I mean by that is taking some of the scientific research that's done, but taking it a step or two further so that it's more usable to resource managers. Sometimes that includes conducting workshops, webinars, developing online tools and reports. And really what I'm going to talk about today is one of the information resources that we have. And this is the Intermountain West Dashboard. So this website, there's not much of this website that is original climate information that Western Water produces, but really it's kind of a clearinghouse for a lot of the information that you've seen today on the Wyoming Conditions Update, that puts all this information right at your fingertips, gives clear infographics on current conditions right now, and then allows you to link to some of those sources if you want to go into greater depth on some of these sources. And this information includes precipitation, temperature, snow, drought, water supply and stream flow information, and seasonal outlooks. And I'm going to kind of finish this up by just giving you kind of a tour of this website. But first, I'm going to see if I can. If you want to follow along, I put the website directly into the chat, I think. There we go. On our home website here, if you go to the very top of the website under resources and click on Intermountain West dashboard, and that brings you to our Intermountain West dashboard. And as you scroll down, it's divided up into some of these different parameters. We organize it first by temperature, precipitation, and snowpack. And if you click on each one of these figures, you get a larger version of that graphic, so you can take a closer look at it. And this is, this figure here is just showing percent normal of precipitation over the last 30 days. This is updated daily. So we have this for temperature, last 30 days of temperature, precipitation, water year precip as a percent of average, current snowpack. As Tony showed, the snowpack is pretty much melted out in most of the West, with some odd numbers down there in the North Platte Basin. We also have figures looking a little more detailed at snowpack. And as an overview, as we work in Colorado, Utah, and Wyoming, the Intermountain West dashboard is providing information for those 3 states specifically, and then in some cases, Western wide. This is one resource that many of you may not have seen. A researcher at the University of Colorado, who's one of our collaborators with Western Water Assessment, has created a technique to estimate SWE across the entirety of the West in a tool called spatial SWE estimates. And this is basically using a combination of satellite imagery and LiDAR data to develop SWE estimates across the entirety of the West. And one of the strengths of this technique is that it provides information where our SNOTEL network is not as robust. So if you actually click on the link, so any of these links on these resources, you can click at the top here, and it brings you to the source of that information. So with this particular source, you can look at the current reports. So these SWE reports are released beginning in February through the end of May, twice a month. And if you actually surf around within this website and get to the actual report, you can get more detailed information on, say, snowpack over certain elevation bands. That's one of the ways that snow information for this product is broken out, that you can look at SWE by basin, but then over bands of elevation, say from 6,000 to 7,000 feet, 7,000 to 8,000 feet. And some of these are elevation bands where we don't have robust coverage of the SNOTEL network. There's also information on drought, various permutations of the U.S. Drought Monitor across the United States and through our region, information on the standardized precipitation index at different time scales. Also, another measure of drought, the evaporative demand drought index. This is a tool that can be especially useful thinking about rapid development of drought and issues like flash drought. This can be a helpful measure of drought for agricultural users. We also have information about current stream flow through each of the 3 states in our region, stream flow across the country, and then seasonal stream flow forecasts, both for the Colorado River Basin that's issued by the NOAA's Colorado Basin River Forecast Center. These figures here are updated monthly with the as each organization issues their stream flow forecasts. And then also seasonal stream flow from the NRCS. We provide this information as well because CBRFC only covers the upper Colorado Basin, whereas NRCS covers the remainder of the region, both for Colorado, Utah, and Wyoming, and also throughout the Western United States. We also provide some information on soil moisture, including surface soil moisture estimates using the NASA GRACE satellite information, and then also estimates of soil moisture anomaly based on NOAA's data. We have a section on reservoir storage. However, the teacup diagrams that are typically here for reservoir storage are not available right now. I'm not sure exactly what's going on, although I will have to say, as probably many of you have seen, there have been interruptions in some of the data streams coming from federal agencies periodically. Hopefully this is just a short-term blip in the availability of the reservoir storage data. Some information on 7-day precipitation forecasts from NOAA, and then information about seasonal climate outlooks. So many of the figures here are those that were shown previously, looking at, say, monthly precipitation outlooks, monthly temperature outlooks, and then the 3-month seasonal precipitation and temperature outlooks. And also one product I wanted to highlight here is this is a product that was created with in conjunction with University of Utah researcher Court Strong, and recent research that he's done, really thinking about seasonal precipitation forecasts for sort of this central portion of the Western United States where El Nino, La Nina forecasts don't really have much predictability. This really came out of work that he and Western Water Assessment has been doing with Salt Lake City Department of Public Utilities for the past decade or so. And Northern Utah really falls in that zone where ENSO, El Nino, La Nina, doesn't really provide any seasonal predictive abilities for this region. So through some of Court's work, looking at not just the impact of Pacific Ocean temperatures on precipitation in the Western United States, but he found connections using Pacific Ocean temperatures and Atlantic Ocean temperatures that provide a predictive pattern for seasonal precipitation in the Western United States. So we turned this research into an online tool that, beginning in November, will provide a forecast for December to March precipitation across the Western United States based on current Pacific Ocean and Atlantic Ocean temperatures. And on the infographic here, this is just showing the most current forecast, which at this point is not really relevant since we've already passed this winter season. But this will begin to be updated starting November 1st of this year for the upcoming water year. And then finally, there's some information about ENSO conditions and forecasts. And a final feature that we have as part of the Intermountain West Climate Dashboard is myself or a colleague at Western Water Assessment publishes a monthly climate summary of Colorado, Wyoming, and Utah each month. And this is usually published between probably about the 3rd and the 10th of each month, and gives a summary really of kind of the topics I've just been showing you information about: precipitation, temperature, stream flow, snowpack, water supply, drought, what the seasonal forecasts are telling us. And then typically we describe one significant weather event that occurred throughout the region. If this is something that you're interested, you can sign up for these briefings to be on our mailing list on the site. And if anyone has really any comments as they use this site, feel free to reach out to me or the email address on our Western Water Assessment site. Or if you're really interested in providing more detailed field feedback, we have a survey that's available here on the top of the Intermountain West dashboard. And with that, I'd be happy to take any questions if there are any. And I'll just type my email into the chat here in case anyone has any additional questions or comments.
All right, thanks, Seth. A lot of information in those graphics. You can spend quite a bit of time perusing those. Let me share my screen back here, or try to anyway. And I'll turn it over to Micah to explain the little survey we got here.
Yeah, thank you, Tony. We have just a brief survey to collect everybody's feedback on the Conditions and Outlooks webinar and the process and content evaluation, just very briefly. So it should be a fairly straightforward process and take less than 2 minutes to complete. You will be prompted to a survey at the end of the webinar. So when it ends here today, it will take you to this link. You're also welcome to scan that QR code if you have a mobile device that will support that.
All right, and then here we'll just, here's everybody who was presenting today, names, affiliations, emails. If you got any questions for any of them, just don't hesitate to drop them a line and we'll all be glad to answer as best as we can.
Absolutely. I'm going to go ahead and stop the recording now, and we will move into our Q&A session with the couple minutes that we have remaining.